If you have a basic shape like triangle, rectangle, circle, you just go to the table. And the formula is right there. Just grab it and compute it, right? But we don't have a formula for this complicated shape. But look, this shape is composed of a quarter of circle, a triangle, and a full solid rectangle. In fact, this shape mathematically is equal to 4 solid rectangle of 2L by 2L subtracted a triangle L by L, a right triangle L by A, subtracted by a quarter of circle with a radius L. There's a mathematical description of that. So what I do, one way is to choose this guy as shape 1, and we know that this is a negative because it's nothing is here, it's a hole, it's empty. And then the full L by L rectangle, full shape number 2, and this one is positive because it actually exists, right? Now, cos a triangle should be subtracted by a triangle, right triangle. And let's call this is shape number 3 and it's negative because nothing is there. Alternatively, you could consider this triangle, the actual triangle here, as 1, 2, 3, 4 subtracted by the 5th quarter of circle. You could do that too. You should get exactly the same result. I recommend when you go home, do the second approach. You should get exactly the same result. So all I need to do is to evaluate this formula. But in order to keep yourself organized, you just go ahead and draw a little table. Shape, standard table, shape number 1, shape number 2, and shape number 3, and this is the sum. That's going to be the sum. So you get x bar I, AI, and x bar I dot AI. And all you need to do is to fill out this table, and then this sum, this is the sum. Excuse me. You need to fill out this table, and this is finally the sum of all these things. This sum divided by this one is the x bar. Look at the formula. The last sum, last column, divided by the sum, second column give you the location of x, location of centroid. Okay? So let's go ahead and fill out this table. For shape 1, where is x bar? Look, whenever we compute the x bar of each individual shape, we should do that computation with respect to the coordinate system that we choose. Now, since the coordinate system is right here, you see this is y, x of coordinate system. Then all the individual centroid must be computed about that point, right? Around that point, or with respect to that point. So if you go to shape number 1, you see the formula. You have a formula: 4 times the radius divided by 3 pi with respect to that coordinate. And fortunately, the good thing is that coordinate coincides with our global coordinate system xy. So all I need to evaluate this x bar, I don't need to transfer it, right? So it's going to be 4 times radius divided by 3 pi. But what is the radius of this circle? Yeah, which is L. Let's solve it parametrically versus L for arbitrary number of L. So that's going to be L. So radius is L, which is 2.5, right? So tell me, what should I write here? X bar 1. 4L over 3 pi. What about area of shape 1? 1/4 of,
The area of the circle.
and what is the area of circle? Pi L squared. This is a second, right? So pi L squared over 4. 1/4 of the entire area. Am I done? What am I missing? So far I'm missing something. I'm trying to ask you what am I missing here? Can you say that?
Negative.
Negative. This shape, this is empty, nothing is here. So we said that the trick is when you have empty area in your shape, just that area is negative. If you it's actually filled up, then you get the positive, right? Time's up. Thank you. So a negative was missing here. I'll put a negative here. Don't forget that. That's very important. When I say double-check result, I mean this kind of mistakes, right? Very small mistakes. Now you go to second shape. Which one is the second shape? The entire 2L by 2L rectangle. So where is x bar 2? What is x bar 2? L. You see that? Is this center of the entire, if this was completely solid, well, the center is here, so with respect to this point, is simply L. See that? Area part 2.
4L squared.
4L squared. Positive or negative? Positive. Because this thing actually exists, it's a solid one. Now let's go to the third one. Again, x bar. X bar for shape 3. In fact, I'm trying to get x bar 3. Well, you know that the centroid of triangle is 1/3, whatever this height is. What is this height? L. So this centroid from here to here, from the base to this point, is 1/3 of L. But look, is that what I need to put in the table? No. I need to find distance from here. You see? Distance with respect to the coordinate system. So it's going to be 2L minus L over 3.
5/3.
Yeah, it's going to be 2L, the entire thing, minus L over 3. So you can put 3 divided by 6 minus 1, 5/3 of L. Right? Positive or negative? Positive. Right? Because it's here. Now you go to area of shape 3. What's the area? This is L and this is L. So it's half of L by L. L squared divided by 2. Is that right? What am I missing?
Negative.
Negative. It's empty. Now, yeah.
How do the 4L square?
This one?
Yeah.
Yes, this one is the area of shape 2, the entire area. So this rectangle is 2L by 2L. So what's the area? So
I thought it would be far from.
no. Look. You have a rectangle. Let's put it here. You have a rectangle like this, and this is 2L, and this is 2L. Now I ask you, what's the area of this?
Okay, I wasn't looking at it like that at first.
Yeah, that's the actual shape that I have. This is the actual shape minus quarter circle minus the triangle. You see that? Now you know, you see what's happening now?
Yeah.
Okay. So now I'm pretty much done with the hard part. The hard part is to figure out what's the Now I got it, right? All I need to do is to multiply this column by this column, put it in this column, and do this sum, and this sum, and divide it together. So the first one, if you multiply these two, this cancel out with this, and you get L cubed, pi goes with that, so you get negative L cubed over 3. You see, 4 cancel out with 4, pi cancel out with pi, negative 1/3 of L cubed. Alternatively, if you are in a test, just put it in the calculator. You don't need to simplify it in your head, because it's going to distract you. Just grab your calculator, put this number in, multiply together, and put the final value here. That's easier. That's working a bunch of numbers using your calculator. But here, you just obviously we have time, so we can do exact algebraic cancellation, analytical cancellation. Now this multiplied by this is going to be 4 L cubed, and this multiplied by this is going to be 5 over 6 negative L cubed. Right? So now the sums. I need this sum, and I need this sum. Is this a column? So the first one, what's the sum of the first column? Well, put it in the calculator. It's going to be, get my calculator running, 4 minus 5 divided by 4 minus 1 divided by 2 is going to be 2 7 1 4, and that's going to be 5. Round it up to L squared. So 2 7 1 5 L squared. Right? The second one will sum to 4 minus 1 over 3 minus 5 over 6. 2.8333. Right? So the final answer would be x bar is equal to this sum divided by this sum. Why? Look at this formula. It's right here. In fact, you're just trying. This table is nothing. Is no new science. It's not. You can just not have table. As a matter of fact, Dalton wrote it in one line without a table. But this table just keep you in organized way, right? If you have like 200 shapes, like I'm pretty sure that at some point you have worked with CAD software like AutoCAD or SolidWorks. Then you have like 200 sub-shapes. Your geometry is actually really complicated geometry, engineering geometry. Then, if you don't have an organized way like a table, it's really hard to keep track of everything. Like if you only have 2-3 sub-shapes, you don't really need a table. But if you have like 200 sub-shapes, you really do need a table. Okay? So let's divide this number by this, and don't forget that this is L cubed. You see, you factor out L cubed here, you factor out L squared here. Now this one divided by this is 2.8 divided by 2.715 is equal to 1.04 times, I will put this 4 times L. Because if you divide this one by this one, L cubed divided by L squared is going to L. So you get 1L multiplied by this number divided by this, which is 1.044. So now go ahead, now it's time to replace L is equal to 2.5 inches, right? That you first, this advantage of this is that you solve it parametrically for arbitrary L. But now if you fix it to 2.5, then I get 1.044 4 times 2.5 inches, which is 2.6, yeah. So 1.044. 2.61. So that's the way you get it. I'm telling you, if you, I saw a lot of students got it, but if you don't get it, and if you don't understand it, and if you couldn't solve it, you need a lot of work. You really need a lot of work. If you continue like that, you're not gonna be an engineer. You just memorize something, go to the next course. Memorize something, go to the next course. And that's going to be a problem for yourself, not for me, for you. Because the more you go, the harder you think it is. And at some point, you just give up and say, I can't even understand what's going on. So if you didn't get this value, or you didn't understand what's going on, and you still don't understand what's going on, then it's a big red alert. Not for me, for you. Not for me, for you. All right? So what we're going to do next class, we're going to give the same geometry, and instead of saying centroid, now compute moment of inertia, Ix, for example. And then maybe not next class, but the class after that. So next class, we're going to work on some example of moment of inertial computation. So all you need is to make a little table like this for moment of inertia. We're going to solve some example, and then the class after that, we're going to do this quiz. So you're going to get the same geometry. Now I'm telling you what the quiz look like. The same geometry, but instead of saying the centroid, you compute moment of inertia. And then after that, we're done with teaching, and then we do really quizzes from frames and friction. All right.